it's off. But if I want to turn it on, I'll press here. You see, if I press on, the bulb is lighting. And you can see within the system, in the PLC, it has commanded the output, the bulb, U-line. And then if I turn it on here also, the bulb is supposed to be going on. So definitely this is one example. You are at location A or you are at flow number 1 and you want to turn on this bulb, you just press this and the bulb is going to be working. And the reverse is true. When you get to the second floor and you want to get rid of this steps bulb or anything, you just press here and it stops working. And the reverse is so guys, welcome to today's video. So today we are going to be sharing about two-way switching, how you can program a PLC to control one element using two switches. It's something which is common in our day-to-day life. Let's say you have a switch here in your first floor and you have to control it, but when you reach at the second floor still you have to control the same bulb. You know, I mean, you cannot go there and then you come back to control the same bulb. But this is just something which is really basic. It has been applied. Two switches can automate it, but we want to just gain knowledge how we can incorporate that in PLC programming. Very easy, but it is a basic, it's a fundamental. You know, we have to start step by step. So if you're new to my videos, you can check up in the previous videos so you can understand a few concepts of PLC. Only one concept can make you fail to understand something. And here, while we are here in this kind of sessions with me, I want the practical reality of lifestyle, not theoretical. Theory we have done it in our bachelor's degrees, in our first year, second year. We have a lot of concepts, but we need to realize these concepts. If it is not by hardware tools, we can do it by software tools and simulation tools. So as when you're in the field, you can understand and visualize everything you're having. So get to this board. It's something in two-way switching. You can be controlling an element, let it be a bulb or it is a pump. I like pumps because I have dealt with pumps in my previous workplace, like most of the times, you know, motors and pumps and generators and stuff. So I want to control a pump or a bulb, and I have two switches. One is at location A and one is at location B. You understand? So this switch I have to control. If I switch on here, this pump or this bulb should produce light. Or if I'm here and I switch on this switch, yeah, if I switch on this switch, this pump should produce light. So in your first year, second year, you have studied something called Boolean. In Boolean, we are only dealing with 0 and 1s. So this is your switch 1 and switch 2. So this is kind of a table that is gonna be realizing this whole concept. So from this, we just gonna generate our program over here. So you have switch 1 and we have how many probabilities? We have it 0, 0 in the combination, or when this one is on, 0 and this one is on, or when this one is on and this one is off, or when they are both on. So when are we going to generate an output? So in this kind of a system, I want it when it is both off or when it is both on, I don't get any output. But when switch number 1 is off, but someone is at this position, switches on, I get an output. The pump should be energized. Or when the reverse, when I'm here and I switch on, yet this one there was no person switch on, and I get the output as well. So from there, I realize this is what we call an XOR gate or an XOR combination. So if I do this XOR combination, I realize I need to write now a program, a PLC. It's gonna be funny for you that it's something very small, but you have to have some concepts to understand it very easily, or it will take you a little bit of some time to internalize. This is what I did in analog electronics, digital electronics, So if I try to see, I don't need this, I don't need this, now I need an equation to give me this, because this is where I need the output. So if I look at this equation, I will see I can get an output here. When A is a complement, when I have no signal at A, but I have a signal at B, plus when I have a signal at A and I don't have a signal at B, is when I'm supposed to be having an output. So this is your whole entire program. This is going to be your entire program. and we shall work unto it to see how to get it. So if I have this equation, I will realize if I'm transforming it into switches, I have A when it is not having anything, then I have also B when it is having a signal. So one is going to be like this and this one is going to be open. I can get an output. And then this one is standing for an O, addition. So this one, that means I'm going to have them in parallel with another signal. When I have A, when A is available, and B, and as well, B is also available, but B is going to be a complement. So let's say this is your A complement, okay, this is your A complement, this is your B, and then this is your A, and then this is your B complement. So realize if I have now this kind, it's going to be giving my bulb to be energized. So this is going to be your entire PLC program that you're going to program. Just write this in ladder programming and then download it in the PLC, leave it, color, everything will be working perfectly. So realize if someone's to see I have an A complement here and I have an A here, then or I have a B here and I have a B complement. So this one is some system we call interlocking. So if someone knows anything about interlocking, you can explain it in the comment section, or in the next video I will start with it and I explain to you interlocking. So as I promised, we are going to be so practical. We are going to be done. We actually have to visualize and to know the system working before we actually get into programming. So here I have tried to incorporate two switches of the system to just show you how they can interact with an output that can be a bulb or a pump or any electrical device. Like when someone is on the first floor, they switch on the switch and then immediately, the light will be working or the pump will be working. And then when they get to the second floor, they will switch off and then still it will get off. Or they can switch on from here and then they switch off from the down floor. Take an example, if you have a pump, you can switch off from location A, switch on, or take a control. So in this kind of a system, it's very small to be using a PLC, but these are small concepts that we have to additively join together to come up to realize, like, to do something complex in PLC. So in here, we have one switch and another switch then controlling one element. So as you can see here, if I press this switch, this one should be working. And if I press this switch, this one should actually be stopping, or the vice versa, you know. So here I had to use simulate application because I want these sections to be interactive and be much more practical than just you hearing knowledge and you don't know how to apply it. So here, if I go to simulate, you can see when all switches are open, there is nothing that is happening. But take an example, you are at location A or you are at floor number 1 and you want to turn on this bulb, you just press this and the bulb is going to be working. And the reverse is true. When you get to the second floor and you want to get rid of this steps bulb or anything, you just press here and it stops working. And the reverse is true. When I'm here and it's open, I can, switch on from here, and when I reach on the down floor, I switch off. So this is the way the power is flowing in this kind of system. So we want to do this using a PLC. So how are we going to do it using a PLC? I'm going to show you how we are going to run it. First, we have to get the program, and then we get into the environment of the PLC. We visualize everything. So, guys, this is the PLC section. Now, I have to program my PLC. If I'm to program my PLC, this is just a simple program. You can just imagine how small it is, you know. You can just imagine how small it is to be, doing this kind of a thing. I need to, increase, yeah. So, this is the entire program. Just imagine you writing this kind of a program and you're just done for the day. So here we have switch 1 and we have switch 2. And as I showed you through via the truth tables, we have to connect switch 1 in series with switch 2, but switch 2 in this kind of a branch is going to be an interlocking switch. So you see, we are using normal closed of switch 2. Then the reverse is true. We have switch 2, and then we use an interlock of switch 1, which is going to be in normal close. And so if we run this kind of a system, it's supposed to be giving us an output when one of the switch is closed. When one of the switch is closed, we are going to be having an output. So this is just the entire program where I have one switch and the second switch, and then I'm controlling one output. So in here, in my comment list, you can actually see in the inputs, I have switch 1 and switch 2, and the outputs, I have only one bar, only one output. So here, this one is just something very simple for us to run. Uh, Take an example. If I want to run, I have to download this program in the PLC. When I'm done downloading the PLC, the program in the PLC, uh, I go online. Once I go online, that means I can. So yeah, there was some issue. I had not turned on this set multiplex. So once I'm online, if I turn this switch on, switch number 1, you can see here we have an input. And if I dare do the same here on, I will not get an output. The reason being, two ons are not going to give us an output. Either of the two is supposed to be on at a go. So if I turn this off, you know, if I turn it off, I'll get an output. And now I want to make it so fun by including in HMI, because here in this kind of a system right now, it can confuse some people a little bit. So I have to include an HMI, that is human machine interface, for you to actually visualize what I'm trying to mean. So I've actually already programmed it. Let me first stop this. I stop this PLC running. I go in offline mode, and then I come here. I've actually programmed. This is when I have programmed the HMI. I programmed one switch and the second switch, and then this is the bulb we are going to be controlling. So I have already compiled it, no errors. It's something which is very simple, and I simulate it. I just, want to be offline while simulating this. So in simulating this, I have to make sure my PLC is running. Like I go to this PLC, I command it to run, and once I command it to run, I also have to go online, and once I go online, I also have to, it's not disabled. Yeah. So once I go there, I now need to bring my screen. This is my human machine interface. This is something people are not going to be seeing. It is within embedded, like it is embedded within the PLC. But this is something which your people are going to be seeing. Let's say it's a factory, or it's somewhere, or it's like in your house, and it's the display you're having. This is what the user interfaces with. This is within the PLC in the control panel. This is what your user interfaces with. Like, say now it's off, but if I want to turn it on, I'll press here. You see, if I press on, the bulb is lighting. And you can see within the system, in the PLC, it has commanded the output, the bulb, you light. And then if I turn it on here also, the bulb is supposed to be going off. So definitely this is what we have been working on to achieve in this kind of a system. And trust me, by the moment you're going to be watching these kinds of videos, up to 10 or 15 sessions of these videos, you'll be able to actually write complete programs for your PLCs. Given an example, star data SATA, where you're not going to incorporate a timer, whatever, you have everything from a PLC. You're supposed to control pumps, you're supposed to control very many devices based on the case scenario your client has given you. So keep on watching these videos. Continue also bringing in your contributions. Let's be one family. If you have something more to share with us, you're welcome.